Okay, so now the other part of this chapter, that's about combinations. So here combination means selection of some or all of the given objects. You are going to select some objects or all objects from the given objects. Now, once we use the word selection, that means your order is not important. Order of selection is not important. Order of selection is not important here. Not important. For example, if I have three objects, let's take n equals to three objects here. Say A, B, C. A, B, C here. Now I'll select any two out of these three. I'll select any two out of these three, right? Any two are selected. So I can take A, B. This is one selection, so we put the curly bracket. Their order is not important. Whether write AB or BA, both are same, remember, because here order is not important. You can write this or this, any one of these two, remember. Next, I can take BC or CB, both are same, remember. Either this or this. Next is AC or CA. Remember, either this or this. So how many total selections? Total number of selections equals to 3. Number of selections equals to 3. 3 selections can be made. 3 selections can be made out of 3 objects. Total number of selections equals to 3. If you remember permutations, this is about combination. If you just recall the permutation, there the order is important. So if I take any two, then you may have AB or BA, remember both. You can have BC and CA both, CB, sorry. Then you can have AC and CA. So these and these are considered as different. Here these and these are different. Here these and these are different. In that case, you have 6 permutations, right? Number of permutations, that is arrangements, equals to 6. 6 permutations can be made out of 3 objects taking 2 at a time. Here how many selections can be made? Only 3 selections. Now how do we write symbolically this one? Total number of objects equals to 3 here. This is a symbol. There we used to write P, here C. 3 total number of objects at a time you are taking 2. 3C2. That is equals to here 3, remember. What's this? This gives us 3C2 is the total number of selections, total number of combinations. Combinations means what? Selections. Total number of combinations of 3 objects taking 2 at a time. 3 objects taking 2 at a time. Taking 2 at a time. This is what combination. 3C2. This is read as 3C2 here. Okay. What is this? Here you know 3P2, that is given by 6. You know the formula also. Total number of permutations. Right? Out of these 2 permutations, you have only 1 selection, remember. Out of these 2, there is only 1 selection or combination. Out of these 2, there is only 1, remember. Right? These 2 are different in permutation, but in combination they are same. So no need to write these 2. So we have dropped this. As a permutation they are different, but as a combination they are same. So this is same as this, and similarly here. Fine. So what is this 3C2? That's the total number of selections or combinations of 3 objects taking 2 at a time. And here this 3 is the total number, so it's always an integer, right? Select combination means what? As I told you, selection of some or all of the given objects, remember. So in general, we use this symbol here. So this is a general symbol, which is we write usually NCR, right? What is this? This is total number of combinations, or selections, you can write selections of n objects, total number of objects, and taking r at a time, taking small r at a time, remember, taking small r at a time. Number of objects equals to r here. So you are selecting r objects out of, remember, n. This is NCR. Read as NCR. Total number of combinations or the selections of n objects taking r at a time. R is always less than or equal to n. You can select all objects, and if you are selecting no objects, that means r is 0. So r is from 0 to n. Okay. One more example if I take. Suppose I'll take again n equals to 3 objects, A, B, C, and r equals to 1. That means I'm taking one at a time. So either you can have A, or you can have B, or you can have C. You are selecting one. So either you can select A or B or C. So here you can say that the 3C1 equals to 1, 2, 3, 3. Remember, 3C1 is 3. Total number of combinations of 3 objects taking one at a time is 3 here. 3 different combinations can be made out of the 3 objects taking one at a time. If I take, suppose here r equals to 3, that is, I'm taking all 3 at a time. So take all A, B, C. So how many selection you could find? Just one. What is this one? Out of the 3 objects taking all at a time. So 3C3 is 1. How many combinations you could find here? Just one. This is the only selection that can be made out of the given 3 objects, and that's only one. So 3C3 is 1, remember. Okay, and 3C2 I already explained here in the previous slide. So 3C2, that is just 3, that way. So this is the concept of combination. Combination means simply selection. If you have mixed question of combination and selection, you notice that whenever there is a question of combination, that means it's a selection, right? Combination means what? Selection. You are selecting something. Their order is not important. Combination means selection. Order is not important. Order is not important. Not important. And what about permutation? Permutation means what? Arrangement. Permutation means arrangement. And whenever you are arranging something, order is important. So here order is important. Order is important. Here order is not important. Permutation means you are arranging something. Combination means you are selecting something. There the order is not important. Here order is important, remember. Okay. Now we go to formula for NCR. Let's go for that. NPR formula, you know. I'll just state the formula for NCR directly without proof. So let me write here formula for NCR. Formula for NCR. What is NCR? Total number of combinations of n objects taking r at a time, and this can be just derived from NPR only. So that's given by here n factorial upon n minus r factorial. This is the formula of NPR upon here r factorial. So in the denominator you have r factorial here, remember, where r is always less than or equal to n and it is greater than or equal to 0. The formula for NCR is this: n factorial upon n minus r factorial into r factorial, where r is from where to where? 0 to n. Remember, r can be 0 and r can be n also, that is all objects are taken together. As we did earlier, if I write 3c2, you know answer to this. Just use this formula: 3 factorial upon 3 minus 2, which is 1 factorial, into r factorial, that's 2 factorial. 3 factorial is 6, 2 factorial is 2. So you have 6 by 2, which is 3. Okay, next, suppose let's write 3c3. What's 3c3? You know it is 1. Total number of combinations of 3 objects taking all at a time. You know that can be done in just way. 3 minus 3, 0 factorial, r, that's 3 factorial, and this is 1. This is 1 and both will get cancelled. So only one selection can be made out of 3 objects taking all at a time. That's what we have noted here, right? You could find just one selection, remember. Okay, next one more. Suppose we want to get 3c1. What's 3c1? That also you did. 3 factorial upon 3 minus 1, 2 factorial, into 1 factorial. Now this is 6. This is 2. 1 factorial is just 1. So again 3. Okay. One more. Suppose I want to do this. 4c2. 4c2 means what? Total number of selections of 4 objects taking 2 at a time. So it would be 4 factorial upon 4 minus 2, 2 factorial upon r factorial, which is this 2 factorial. 4 factorial you know, otherwise you can write this bigger factorial in terms of the smaller factorial. 4 into 3 into 2 factorial upon 2 factorial. So this will get cancelled. 2 factorial is just 2. 4 3 are 12 by 2. So 6 combinations can be made out of 4 objects taking 2 at a time. For example, see here, if you want to see, suppose I have 4 objects A, B, C and D. I'm taking 2 at a time. So one you can take AB, then you can take AC, then you can take AD, then you can take, can we take BA? No, you cannot take BA because BA is same as AB. So you can have your BC. Can I take BD? Yes. So I'll have BD here. Then can I take CA? No, because AC is already there. Can I take CB? No, because BC is already there. Can I take CD here? You can see that CD or DC is not there. So CD. Then can I take DA? No, because AD is there. Can I take DB? DB you cannot because BD is there. Can I take DC? No, because here it is there. So you can see 1, 2, 3, 4, 5, 6. How many selections you could find out of total 4 objects taking 2 at a time? That is 1, 2, 3, 4, 5, 6, and that's why this is 6, remember. Total number of selections of 4 objects taking 2 at a time, which is denoted by this symbol 4C2, and which is 6 here because of just the 6 selections, you can see, as we did in permutation. In permutation we were just arranging, here we are just selecting. That's the difference, remember. In permutation you are arranging, in combination you are selecting, remember. So order is not important. Okay, and what's the important formula here? Important formula is this: NCR is n factorial upon n minus r factorial into r factorial. What is NCR? N factorial upon n minus r factorial into r factorial. Okay, now we just discuss some results which are based on this combination symbol here. So let me write here some results. The one that is NC0 if you find, and if you find NCN, NC0 means what? No objects being selected. no objects being selected, which can be done in one way. And what is NCN? All objects are selected. That you take all objects. This is always 1, remember, like this. So NC0 is 1, NCN is also 1. You can just use the formula. You look at that formula, you see what is NCN? N factorial upon n minus n, 0 factorial into n factorial. So 0 factorial is 1, this will get cancelled, right? Because of this, as you have it. That's why NCN is 1. So if you have 4C4, it is 1. If you have 2C2, that is 1. If you have 7C7, that is 1. What is 5C0? Which is also 1. Number of ways of selecting no objects. All are taken together, then that is 1. Just to remind you, if you remember, what was, for example, 4P4? It was 4 factorial, remember. If you just recall NPN, that was n factorial. Okay, here it is 1, just to remind you. Okay, that's 1. 1 is this result. The second result is you you just get here, for example, let's write 4C2. I'm finding, okay, 4C3. Let me find this, which is 4 factorial upon 4 minus 3, 1 factorial into 3 factorial. So this you can write 4 into 1 less 3 factorial upon 3 factorial. So here it is just 4. I'll get the 4C1. What's 4C1? Let me find this. 4 factorial upon 4 minus 1, which is 3 factorial into 1 factorial. Simplify this. 4 into 1 less, we stop, 3 factorial upon 3 factorial. So again 4. See, these two are equal. So what we have noticed in this 2 is, if the sum of these two lower numbers equals to the above number, then these two values are equal. So this is next important result. If your NCR, N, NC, N minus R, these two are always equal, remember. See what we have noticed? You just take the summation of these two. आप इसका और इसका summation देखो, ये ऊपर वाला number आ जाएगा. Then the value are always equal. Fine? Like this. If I write as an example 4C, let us write 1 and 4C3. ये दोनों equally होगा क्योंकि ये दोनों का summation ऊपर वाला number है. You can just verify. That's what this result says. If I find, let's write 5C2 equals to 5C, क्या लिखना चाहिए? 3, because sum of these two is above number. Okay, one more. Suppose I'll write 9C2. So that's equals to here 9C, this is 7. Why? Because sum of these two is above number. Summation of these two, n plus n minus r. ये दोनों का आप समेशन करो तो n आ रहा है, which is this above number, ऊपर वाला नंबर आ रहा है, देखो. That's what this result says. It can be proved very easily. इसकी फार्मूला लिखो, इसकी फार्मूला तो आपको पता है, तो these two are always equal. NCR is equals to NC n minus r. How do we remember this? Sum of these two, summation of lower numbers, sorry here r, I'm sorry. Sum of these two lower numbers r and n minus r gives us this above number. Right? That's what I'm trying to tell you here. 4C1, 4C3 are always equal. One more example, if I write here like this. If I write, let's write 7C3, and if I write 7C here 4, this 2 would be equal because the summation of these two is above number. If I write 11C4 and if I write 11C7, sum of these two is above number, so these two are equal. Okay, so this is what the important result, remember. Sum of these two should be above number, then this combination values are equal. Fine. One more, third result here. Let me write third result. Third result says that that's about the addition of two combination symbols. if you have NCR plus NCR minus 1 equals to, what we observe about this left hand side, what we observe, these two numbers should be same, number 1, and here difference should be 1 only, right? Like this, for example, मैं यहाँ पे लिखूँ 4C2 and I'll find 4C, these two are equal. यहाँ पे एक का difference होना चाहिए, either मैं 3 ले लूँ या 1 ले लूँ, suppose मैं 1 ले लूँ, right? This is one example. One more, suppose, let me write here, suppose I have 5C2 plus here 5C, ये दोनों नंबर इक्वल होना चाहिए, यहाँ पे एक का ही डिफरेंस होना चाहिए, सपोज मैं 3 ले लूँ, ये दोनों में मैक्सिमम डिफरेंस 1 होना चाहिए, ये देखो दोनों में डिफरेंस कितना है, 1 का ही है. Then this result says that it can be proved also, not a big task, remember. You write the formula for this, so you'll get this. Above number plus 1, so n plus 1, and you select the bigger of these two. Which is the bigger of this? That is r, bigger number. So here what should be your answer? Above number plus 1, select the bigger of these two. The answer would be 5C2. Above number plus 1, 6C. What's the bigger of this? 3. You can verify. You just find 4C2, find 4C1, 5C2. You add these two, you'll get exactly this. Right? Or एक example लिखूँ. Suppose I have 7C2 plus 7C3. So what's the answer? 7 plus 1, 8, and bigger of this, 8C3. Let us verify for this. This is always true, remember, it can be proved. Start with LHS, add them, simplify, you will get RHS. Okay? See, here, let me find the value of this. What is this? 5 factorial upon 5 minus 2, which is 3 factorial into 2 factorial. Plus, what about this? 5 factorial upon 5 minus 3, which is 2 factorial into 3 factorial. Fine. So here, how do we simplify? 5 into 4. So 3 factorial will get cancelled. 20 by 2. So this is 10 and this is also 10. So we'll get the 20 on the left hand side. What about RHS? Let me see this. 6 factorial upon 6 minus 3 factorial into 3 factorial. So I can write the bigger factorial in terms of the smaller factorial. So 6 into 5 into 4. यहाँ पे और एक 3 factorial आएगा up to 3 factorial and this 3 factorial will get cancelled. ये जो 3 factorial है इसका value लिख दो which is 6. So that will get cancelled with this. You are left with how much? 20. You can see the left hand side addition was 20. RHS is also 20. So these two are equal. So freely you can use this. If I write one more here, suppose I have 11C 9 plus 11C10, then what's the answer to this two? Above number plus 1, इसमें plus 1 कर दो और इसमें से bigger number ले लो which is 10. This is always true. Okay, let me give the proof of this. That's nice because that gives the practice of NCR formula also. So I'll try to prove this. I'll start with LHS here and I'll get the RHS. I'll start with left hand side here. Let me give the proof here. Proof is not important, but it's a good practice. So what's this LHS? N factorial upon this minus this, which is n minus r factorial into r factorial plus what about this? Here n factorial upon this minus this, ये पूरा minus में जाएगा, तो what you will get? N minus r plus 1 factorial into r minus 1 factorial. Fine. I've just written the formula. क्या होगा formula? N factorial upon n minus r minus 1 inside the bracket. So if you open the bracket here, n minus r plus 1 factorial into this much, which is r factorial. Now this is equals to, see, First you can find n factorial common, that's one thing. Okay, so let me keep right now this one as it is. You can see out of these two, this is bigger factorial. So what we do is here, I can express the bigger factorial in terms of the smaller factorial. So I'll take this form now here. Is this into एक less कर दो तो 1 less n minus r plus 1 minus 1 less, that is this factor. ये दोनों में से विच इज़ अ स्मॉलर फैक्टोरियल, दैट इज r माइनस 1. तो r फैक्टोरियल को आप क्या लिखेंगे, r इंटू 1 लेस, दैट इज r माइनस 1 फैक्टोरियल. सो यहाँ पे बाजू में a अभी तो बाकी है, दैट इज r माइनस 1 फैक्टोरियल. फाइन. What I did, I have expressed bigger factorial in terms of a smaller factorial, और कुछ नहीं किया है. ये दोनों में से a और a दोनों में से विच इज़ अ स्मॉलर, दैट इज दिस वन. तो इसको मैंने a फॉर्म में लिख दिया. n माइनस आर प्लस 1 एक लेस कर दिया, तो n माइनस आर. सपोज ये 3 फैक्टोरियल होता तो आई वुड हैव रिटन 3 इंटू 2 फैक्टोरियल. सपोज ये 7 फैक्टोरियल होता तो आई वुड हैव रिटन 7 इंटू 6 फैक्टोरियल. ये दोनों में से आप जानते दिस इज अ स्मॉलर, सो आई हैव एक्सप्रेस दिस वन इन दिस फॉर्म. सपोज ये 9 फैक्टोरियल होता तो आई वुड हैव रिटन 9 इंटू 8 फैक्टोरियल. फाइन. ओके, नाउ वी जस्ट टेक नंबर ऑफ थिंग्स कॉमन हियर. n फैक्टोरियल कॉमन, और क्या कॉमन है, n माइनस आर फैक्टोरियल भी कॉमन है, एंड r माइनस 1 फैक्टोरियल भी कॉमन है. इतना कॉमन है. सो व्हाट विल गेट इनसाइड द ब्रैकेट हियर, a कॉमन आ गया, a कॉमन आ गया, a कॉमन आ गया. सो जस्ट 1 बाय r प्लस व्हाट अबाउट दिस हियर 1 अपॉन दिस आई हैव टेकन कॉमन, दिस आई हैव कॉमन. सो n माइनस r प्लस 1. So this is equals to here n factorial upon n minus r factorial into r minus 1 factorial, and you just simplify this. If I simplify this, here numerator में आपको just n plus 1 ही बचेगा. And what about the denominator? Denominator में दोनों का product बचेगा, that is r into n minus r plus 1. So finally just take the cross multiplication. So you have this. Now 3 factorial into 4 होता तो आप 4 factorial लिखते हैं, तो यहाँ पे n plus 1 factorial. If I have like this, देखो suppose मेरे पास 3 factorial into 4 है, तो how do I write this 4 factorial. So यहाँ पे n factorial into n plus 1, so n plus 1 factorial. इसका नेक्स्ट टर्म यहाँ पे प्रेजेंट ही है, तो ये दोनों को आप कंबाइन करेंगे तो क्या होगा, n माइनस आर प्लस 1 फैक्टोरियल. और ये दोनों का भी इसका नेक्स्ट टर्म यहाँ पे है, तो r प्लस 1 फैक्टोरियल. और ये और कुछ नहीं है, दिस इज n प्लस 1 c r, रिमेंबर, राइट. देन दैट्स योर RHS, दैट इज योर RHS. इसका फॉर्मूला लिखो, यही मिलेगा n plus 1 factorial, n plus 1 minus r factorial into, I'm sorry, ये दोनों का r factorial होगा, not r minus 1 and next number r. So here you will get the r factorial. I'm sorry, please. So you have this. I repeat, ये देखो, you combine these two, r minus 1 factorial into r, so r factorial. I hope this is clear to you. This is not important for examination point of view, but just for your information, I just did for you. Important one is how to use the formula. Okay. Now, next property is this. If two combination symbols are equal, NCA and NCB. Above number equal, I remember. If two combination symbols are equal, it implies we have two things. Either A equals to B, or the sum of these two is above number. Right? This is always true. अब देखो, you know this thing. Suppose मैं 7C2 लिखूँ, तो दैट इज ऑलवेज इक्वल्स टू 7C2. तो ये दोनों सिंबल्स इक्वल है, यहाँ पे दोनों इक्वल हो गया. व्हाट इज़ द अदर पॉसिबिलिटी? मैं 7C2 लिखूँ तो आप जानते हैं बाय वन ऑफ द प्रॉपर्टी ये 5 भी हो सकता है, तो भी इक्वल होगा. दैट मीन्स यहाँ पे ये दोनों का समेशन आपके देखो तो ऊपर वाला नंबर हो गया. गेटिंग मी? सो either these two are equal or the sum of these two is above number. One more example. If I write 9C3, so that is obviously equals to 9C3. ये दोनों तो equal ही होगा. What is the other possibility? 9C3 लिखो, so that might be equals to 9C. May have 6. Remember, तो भी equal होगा. Because here sum of these two is above number. So two combination symbols are equal. It means either these two numbers are equal or the sum of these two is above number. Remember, this is always true. Fine. And finally, last one, there is a relation between NCR and NPR. If I write the formula for NCR, this is n factorial upon n minus r factorial into r factorial. और ये आप जानते हैं दिस इज NPR. सो NCR इक्वल्स टू व्हाट इज दिस? दिस इज NPR अपॉन r factorial. और दैट इज सेम एज यू कैन राइट NPR इक्वल्स टू r factorial into NCR. This is always true whichever you write. Whether you write this or this, both are same. This is always true. This is the relation between NPR and NCR. Fine. Always true, remember. Here NCR symbol is also denoted by this, this NCR, which is also sometimes denoted by this here. NR, and we write this round bracket. This is also read as NCR. If I write 4C2, that's also sometimes written as 4C2, like this. Just round bracket. If I write 7C2, that is 7C2, like this. Just put the round bracket for NCR. This is read as NCR, 4C2, 7C2. Another standard notation. Not like this, remember. Not like this. Just put the in a round bracket, round parenthesis, 4C2, 7C2, 11C4, 9C1, 8C4, like this. We use such symbols here, remember.